Great. Okay, so that's right. So when you click on this one, it'll take you to it'll take you to the and when you click on the resources, it'll take you to the page about that particular topic. And the video shows you how to get around these pages. We're going to go to the resource for this topic. We got some practice questions once it finally loads up. But first thing I want to look up is the simulations. So click on simulations, and I think a good one to look at first, then, if we're going to learn about atoms, is this one here actually. So this is quite a cool simulation. It's called Scale of the Universe. I want to go British. Yeah. And no, not Chinese. Okay. So this is a simulation which allows you to zoom in and see what everything's made out of. So this circle, it says 1 meter. It means that this circle is 1 meter across. All right, and we're going to zoom in, and we can see here's a shrew. This is a quail's egg. This is the length of a microwave. All right, you're going to learn about waves eventually. That's a penny. Keep scrolling in. That's how big an ant is. Now this circle is only 1 millimeter across. Okay. Now we've got a bit of bacteria that is that big. A grain of salt is that big at this scale. We're trying to see how big is an atom. Okay, or how small is an atom. At this stage, remember this is 1 millimeter across. That's how thick a piece of paper is. That's the width of a human hair. Let's scroll in even further. This is how big a human cell is. This is a white blood cell here. That's a skin cell, that one was. Keep scrolling in. We can see a bunch of other things. I'm not going to look at all of them. We're now at a micrometer. This is 1 millionth of a meter, or 1,000th of a meter. We still can't see any atoms yet. Remember, all these things we're looking at actually are made out of atoms, apart from the wave. Keep scrolling in even further. We've got a transistor gate. This is actually something that all microchips nowadays in your phone and the computer we're using right now are made out of these transistor gates, which are very, very tiny. Let's scroll down even further. Now we've got a glucose molecule. Now we can actually see the individual atoms here. The red, the black, and the white circles. Let's zoom in on that. We can't actually. Okay. So the black circle are carbon atoms, the red circles are oxygen atoms, and the white circles are hydrogen atoms. You can see here, this is our first atom called a cesium atom, very large atom. Let's scroll down even further. We have a carbon atom. We got our first atom. So what's an atom made out of? Well, we got these yellow things around the outside. These are the electrons, okay? And the red thing in the middle, that's its nucleus. But the nucleus is made out of things too. We keep scrolling down even further. We're now looking at a hydrogen atom. And a helium atom. Now the red thing is something different. In this case, the red thing is just a proton. In this case, we've got 2 protons, and then we've got 2 grey things. So they're the neutrons. Now we get an idea of how small an atom is. So atoms are incredibly tiny. If we zoom out, we've got how big is that? That is a billionth of a meter across, or a millionth of a millimeter. Okay, so very, 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 very tiny. So let's have a look at a different simulation now, and we're going to try to build an atom. So we're going to go to build an atom here. In fact, what I'm going to do, I'm going to label these with your name so you'll be able to find them yourself later on. I'm just going to pause the video for this bit here. So we're going to build an atom now. So we click on the link. Takes us straight to the place. Press play for the simulation. And this is from PHCT. I use this a lot. So we're going to make an atom. So let's re-ask that question. What are atoms made out of? What do you reckon is the answer now? Right, yeah. Atoms are made out of protons, neutrons, and electrons. Now, let's see what happens when we start to add these protons, neutrons, and electrons. If I added 1 proton and let go, what changed? Well, we got a name, hydrogen. It called itself an ion. and it has a charge of +1. So that's right. So the charge went up to 1. You can see the little arrows moved off to the right. The mass is 1. It's called itself hydrogen, and that's changed to that's been highlighted 2, and it's a plus ion. Now I'm going to add an electron. I'm going to see what happens. So the electron put the charge back down to 0, and now it calls itself a neutral atom. The name stayed the same, and the mass number stayed the same. Now, why do you think that might be? It's not that they got the same, because if the electron was the same mass as hydrogen, that mass number would be 2 now. But the fact is that electrons are extremely light. We basically say they have a mass number of 0. It's not completely true. They do have mass, but it's very, very tiny. So when I start adding electrons, the mass number doesn't go up. It just stays the same. It doesn't affect it. But what it does change is the charge. So electrons have a charge of -1. So when I add electrons, it becomes more negative. When I take them away, it becomes less negative or more positive. And it can also see that the protons, remember the protons were positive, so they're gonna cancel out with the electrons. So if we want to make the net charge 0 and make it a neutral atom, we need to make the protons and the electrons be the same. Okay, so let's just pause there, and we'll come back to this in a moment. And let's make a few notes on what we've learned so far. Okay. Okay, so we've learnt that the mass of a proton is 1. So when I add more protons, the mass goes up by 1. And no matter how many electrons I add, well, at least in this simulation, the mass stays the same, because the electrons are very, very light and they don't affect the mass. But they do affect the charge. That's because electrons are negative. So protons are positive, electrons are negative. And also notice that the name only changes if I add protons. So if I have 2 protons, it's helium, and we can see it highlights it on the periodic table there. 3 protons. What do you think 3 protons is going to be? You don't have to tell me the name of the element. You could just tell me maybe the symbol. What do you think What do you think it will be when I add another proton? Right. So when I add another proton, it's lithium, Li. So what happens if we add another proton? Exactly, good. So when I add another proton, it's Be, beryllium. What about the next proton? What's that going to be? Yeah, it jumps ahead because it's straight to boron. So basically, as you add protons, it goes from left to right. When it gets to the end, it goes back to the beginning again. Okay, like that. Now, if we let's go back to lithium. So lithium it's the third one, so it has only 3 protons. And we're going to find what lithium. We're going to get a symbol. In fact, I'm going to just draw the symbol. If you get a proper periodic table like the one we've got on our whiteboard, in fact, we can just have a look at that now. If we go to our whiteboard, we can see that it has an atomic number or relative atomic mass of 7 and a proton number of 3. Okay, so what I can do is I can just take a cut of that, and then what we'll do is I'll just shrink that. And can I shrink it? Oh, I can't. That's as small as I can make it. No problem. So I put that there, and now we've got. I'll put it somewhere where. There we go. Right. So now we can see what the symbol is, and we've got a mass number of 7 and an atomic number of 3. Now, the atomic number is what tells you the number of protons. Try to remember this because I'm going to ask you about this later on. The atomic number is the number of protons. The mass number is this number here. So I can't give it. We know we need a mass number of 7, but if I add protons, it's no longer lithium. Okay, so I need to add something else to increase the mass number. So what do you think I need to add to increase the mass number? Very good. So, what do you think the mass number will be when I add one neutron? And the mass number currently is 3. The mass number of a neutron is 1, so it goes up to 4. So how many more neutrons do I need to add to get it up to 7? Yes, exactly, yeah. Brilliant, brilliant. So we've got 3 protons. We want to get we want to have 4 neutrons, and it's still lithium because the neutrons does not affect the name of the element. Only the protons do. And so, but the protons also affect the mass number. The other thing that affects the mass number is the neutrons. So we have a total mass number of 7 because we have 3 protons and 4 neutrons. The ion, it's currently an ion. It's currently got a negative charge. So how can I make it a neutral atom? Basically, what we need to do is take the electrons away rather than add them. So when I take it away, it goes up to -1. We're reducing the negative charges, and now we take it away again, and now it's to 0 charge because we need the same number of protons as electrons. So all neutral atoms have got the same number of protons as electrons. However, you can have ions, which we saw earlier on when we had too many. It was called an ion. This is a negative ion. But atoms prefer to have a full outer shell. So sometimes they do form ions. So this lithium atom, if the easiest way for it to have a full outer shell would be to lose this one here, and now it's just got this shell, which is full. See, the first shell can hold up to 2 electrons, and the second shell can hold up to 8. So when I take the 1 electron away, then it's got only 1 shell, and that shell is full. So, so lithium, if it forms an ion, it will lose 1 electron, and it will be a +1 ion. And actually, that's the same with all metals. But when it's neutral, it has 3 electrons there, 2 in the first shell and 1 in the second shell. Okay, so I'm going to stop the video there, and we'll save it into your whiteboard. And I'm going to ask a few questions to see what you can remember from what I said. But remember also all the answers are going to be on the video whenever you want to rewatch it. Okay, so I'll just stop that. Let's try again. Stop it over here.